The first nodes we are going to look at are called the input and output nodes. The first section in this is the constant nodes. Constant nodes are input nodes that provide fixed values such as numbers, colors, strings, or other data types to be used across a node tree. The first node is a Boolean node. This node gives a single Boolean value, either false or true. Next node in the list is the color node. This node basically allows you to choose a color. Moving on, we got the image node. This node lets you load an image file into the geometry node editor. Next up, we got the integer node. Like the name suggests, this node provides an integer value. Next is the material input node. This node gives you access to materials in the geometry node editor. Next is the rotation input node. This node allows you to control rotations. The string node lets you output a string value. The vector node basically creates a vector. The value node outputs a single numerical value. Coming up next, we got the collection node. This node allows you to input a collection into multiple sockets throughout the node tree. Last but not the least, object node. This allows you to input a singular object throughout the node tree. The next set of nodes are called scene data nodes. They allow for a dynamic interaction between scene elements and geometry nodes. The first of this set is the active camera node. This node outputs the scene's current active camera. Next is the collection info node. To access a collection in the geometry node editor, you can simply type its name in this text box, or you can simply drag a collection from the outliner into the geometry node editor. Moving on, we got the object info node. This node retrieves data from selected objects from the outliner. Next is the image info node. This node is used to retrieve data from images or videos. Moving on, we got the is viewport node. This node outputs a true value when a set of geometry nodes is evaluated for the viewport and false for the final render. Up next, we got the scene time node. This node outputs the current time in the scene's animation in units of seconds or frames. The next set of nodes we're going to look at are called attribute nodes. The first of the set is the attribute statistic node. This node performs statistical operations such as mean, median, sum, finding the minimum or the maximum on a given attribute. Next up, we have the domain size node. This node basically tells you how many points, edges, or faces, or any other geometric element are present in a given mesh. Next up is the blur attribute node. This node basically smoothens the attribute values. Next up is the capture attribute node. This node saves the result of a field onto the geometry and makes it available for other nodes. Next up is the remove named attribute node. This node deletes a specific attribute with a certain name from the geometry. Removing unused attributes can improve performance and reduce memory usage. The last node in this set is the store named attribute node. This node saves the result of a field onto the geometry as an attribute with a specific name. It's like the capture attribute node, but instead you can give it a name. Before we go ahead, I just want to take a few moments to talk about this project. This basically started out as notes for myself to understand geometry nodes, and well, it has turned into this full-blown project where I'm explaining geometry nodes, and what I have discovered is that geometry nodes is insanely fucking detailed. The more I study it, the more I play with it, the more nuances I find with it, and hence I definitely cannot cover everything in this video, and that's why I made all my notes that I used to study geometry nodes into an ebook. And also I created another ebook called Nodal. This book contains a recipe style step-by-step explanation of 20 geometry node exercises that I went through that changed and built my understanding of geometry nodes the most. This book will actually take you from 0 hours to 200 hours of experience in geometry nodes within the course of that book. And if you want to check out any of these stuff, they're on Gumroad and Blender Market. And I just want to say thank you for watching. This means a lot to me. So let's get on with the rest of the video. The next section is called the curve nodes. The first set of these nodes are called primitive nodes. These nodes include the arc node, which generates a polyspline arc, the Bezier segment node, which generates a 2D Bezier spline from the given control points, the curve circle node, which generates a polyspline circle, the curve line node, which generates a polyspline line, the curve spiral node, which generates a polyspline in a spiral shape, the quadratic Bezier node, this generates a parabola type shape, the quadrilateral node, which generates a polygon from 4 points, and the star node, which generates a star shaped polyspline. The next set of nodes we are going to cover are called output nodes. The first two nodes we're going to cover are the group input and output nodes. These are the first two nodes you see when you open the geometry node editor. The group input node gives you access to the node's group input sockets from the inside. These sockets act like external controls, letting you tweak stuff like values, colors, or geometry from outside by connecting them to the nodes inside. The group output node decides what data gets sent out of your node group or your geometry node setup. Only what you connect here shows up as outputs. This can include attributes, geometries, booleans, values, anything really. The next node is the warning node. This node basically outputs a custom message when an error occurs. The last node in this section is the viewer node. This node lets you see parts of a geometry node tree by only evaluating the nodes that come before it. The next few nodes are called material nodes. These nodes are used to apply and manipulate materials. The first of these nodes is the set material node. This node basically assigns a material in a specified selection of your procedurally created geometry. Next is the replace material node. This node basically swaps one material with another. It has an input for the old material and an input for the new material which needs to be swapped. Next is the material selection node. This node provides a selection for all the meshes that use a specified material. The set material index node and the material index node take advantage of this. The set material index node basically assigns an index to materials. The material index node retrieves these indices to be used in the geometry node tree. Coming up next, we got the UV nodes. The first of this node is the pack UV islands node. This node scales and moves UV islands to fill the UV space as efficiently as possible. The next node is the UV unwrap node. This node generates a UV map based on a selection boolean of seam edges. The next set of nodes are called texture nodes. These are the same procedural textures that have been ported over from the shader editor. So I'll just quickly run through all of them. We got the brick texture node, the checker texture node, the Gabor texture node, the gradient texture node, the image texture node, magic texture node, noise texture node, Voronoi texture node, wave texture node, and white noise texture node. Mesh primitive nodes enable you to bring basic geometry shapes directly into the geometry editor. Mesh nodes include, first we got the cone node, then we got the cube node, then we got the cylinder node, up next we got the grid node, the icosphere node, the mesh circle node, the mesh line node, and the UV sphere node. The next set of nodes are called point nodes. These nodes deal with distribution, conversion, and generation of points. The first node in the list is distribute points in volume node. As the name suggests, this node basically distributes points in a given volume. Next is the distribute points on faces node. The name speaks for itself. It basically distributes points on selected faces. Next is the points node. This node generates a point cloud with a given position field with points of a specific radius. Coming up, we got the points to curve node. This node generates a curve geometry by taking points and inserting them into a new curve. The next in the list is the points to vertices node. This node creates a mesh vertex in the output geometry for every point in the input point cloud. Next we got points to volume node. This node basically creates a fog volume sphere around every point based on a density and a radius value. Next up we got set point radius node. This node controls the size of each selected point in a point cloud. Okay, the next set of nodes come under the read section in the geometry nodes part. The first of this node is the ID node. This node basically retrieves the ID attribute which we discussed earlier. Up next on the list, we have the index node. This node gives an integer value or the index indicating the position of each element in the list, starting from 0. Moving on, we got the normal node. This node outputs a vector showing the normal direction at each evaluated point. Coming up, we got the radius node. This node outputs the radius value at each point on the evaluated geometry. Next, we got the position node. This node outputs a position vector of each evaluated point in a geometry. The next set of nodes come under the sample section. The first of this node is the really powerful geometry proximity node. This node allows you to compute the closest location on a target geometry from a sample position. Next, we got the sample index node. This node allows you to retrieve a specific attribute from a source geometry at a given index. Up next on the list, we got the sample nearest node. This node retrieves the index of the geometry element in its input geometry that is closest to the input position. Moving on, we got the index of nearest node. This node returns the index of the nearest point for every other point in the geometry. Up next, we got the raycast node, another really powerful node that casts rays from one geometry onto another, finding hit points on the target mesh. The node outputs the normals, distances, and any specified surface attribute at each point. The next set of nodes come under the right section. First of these nodes is the set ID node. This node fills the ID attribute on the input geometry. Moving on, we got the set position node. This node allows you to control the location of each point in a given geometry. Next up, we got the set geometry name node. This node allows you to set a name for the input geometry. The next section is arguably the most important section in geometry nodes, so pay attention, kids. The first of this set is the bake node. This node saves and loads intermediate geometries for improved performance by baking parts of a node tree. Next up, we got the bounding box node. This node creates a bounding box with the least volume that encapsulates the input geometry. Next up, we got the convex hull node. This node outputs the convex hull of a given geometry. Moving on, we got the delete geometry node. This node removes selected parts of a geometry. Coming up next, we got the duplicate elements node. This node creates new geometry by duplicating the input geometry. Moving on, we got the merge by distance node. This node takes an input geometry and merges vertices or points within a specified distance. Next, we got split to instance node. This node basically splits up geometry elements into instances based on a group ID. Next up on the list is the sort elements node. This node rearranges geometry elements by changing their indices. Coming up is the transform geometry node. This node moves, rotates, and scales the entire input geometry. Next up, we got the separate component node. This node splits an input geometry into its individual components. Moving on, we got the separate geometry node. The separate geometry node produces two geometry outputs based on the selection input provided. The next section is the miscellaneous category. First in this list is the join geometry node. This node basically merges separately generated geometries into a single bigger geometry. Up next on the list is the geometry to instance node. This node converts multiple input geometries into instances. The next set of nodes are called utility nodes. First of these nodes is the black body node. It basically gives the color output that corresponds to the color emitted by a body at a specific temperature. Next is the color ramp node. If you have any idea of what it does in the shader editor, it basically does the same thing in geometry nodes. Next, we have the combine color node. This node combines individual channels into one color image. Next up, we have the separate color node. This node basically separates an image into its elemental channels. Next up, we have the RGB curves node. This node can perform level adjustments on each color channel or on all the color channels as a whole. The next set of nodes come under the text category. First in this set is the string to curves node. This node converts a text input into curves. The next node is the join strings node. This node combines any number of input strings into one single string. Next is the replace string node. This node replaces a string segment into another string. The next node is the slice string node. This node basically allows you to extract a string segment from a larger string. Next is the special characters node. This node is used to output string characters that can't be directly typed with the keyboard. Last of the text nodes is the value to string node, which basically converts a numerical value, which could be a float or an integer, to a string. The next set of nodes are the vector utility nodes. First in this is the vector curves node. This node takes a vector as input and maps it to a curve. The next node is the vector math node, which basically does vector math. The next node is the vector rotate node. This node takes a pivot point as an input and allows you to rotate a vector about that pivot point. The next node is a combine XYZ node, which combines individual X, Y, and Z components into a single vector. Next, we have the separate XYZ node. This node breaks a vector into its individual XYZ components. Right, now we can move on to the rotation nodes. The first of this node is align rotation to vector node. This node basically aligns a specified axis to a specified vector. Next up, we got axis to rotation node. This node basically allows you to create a rotation based on the direction of two axes. Next, we got axis angle to rotation node. This node allows you to create a rotation based on the direction of a single axis and an angle about that axis. Next, we have Euler to rotation node. This is a pretty self-evident node. It creates a rotation depending on the Euler rotation values. Next is the invert rotation node. This node inverts a given rotation. Inverting is the same as adding a minus sign to your rotation. Next is the rotate rotation node. This node adds a specified amount of rotation to an already given amount of rotation. Next is the rotate vector node. This node allows you to rotate a vector by a given amount. The output is in the form of a vector. Next is a rotation to Euler node. This node converts a given rotation to standard Euler form of rotation. Next is a rotation to quaternion node. This node converts a given rotation to the standard quaternion form of rotation. Next is the quaternion to rotation node. This node converts a given quaternion rotation to standard rotation form. The next set of nodes are deprecated nodes. Don't use these nodes at any cost. The two nodes in this are Euler to rotation node and rotate Euler node. The next set of nodes we are going to cover are called import nodes. These nodes allow you to bring in external data into the geometry node editor. The first node we will look at is the import CSV node. This node lets you bring in CSV files and turn them into a point cloud, which allows visualizing external data in geometry nodes. Up next is the import OBJ node. This just lets you bring in OBJ files directly into the geometry node editor. Up next, we got the import STL node. This node brings in mesh geometry from a .stl file. These files are common in 3D printing and CAD softwares. Up next, we got the import PLY node. This node brings in mesh data from .ply files. These files usually come from 3D scanning or modeling software. Up next, we got the import text node. This node reads plain text files and spits out the entire content as a single string. And the last node in this list is the import VBD node. This node loads volumetric data from a .vbd file and it outputs it as a volume geometry. The first of these nodes is the combined matrix node. This node constructs a 4x4 matrix from its individual values. Next is a combined transform node. In Blender, transformation, rotation, and scale can be represented in the form of vectors. These vectors can be represented as columns in a matrix. This node just enables you to create that matrix. Next is the invert matrix node. Inverting a matrix is a mathematical operation and this node just enables that. Next is the determinant matrix node. Determinant is a value that can be derived from any square matrix and this node just allows you to find that. Next is the multiply matrix node. This node just allows you to multiply two matrices. Next is the transform direction node. This node allows you to multiply a transformation matrix with a given direction vector. Next is a separate transform node. This node basically allows you to separate a transformation matrix into its translation vector, rotation vector, and scale vector. Next is the point project node. This node applies a projection matrix to a point. Next is a transform point node. This node applies a transformation matrix to a position vector. Next is a transpose matrix node. Transposing a matrix is a mathematical operation and this node just enables that. The next few nodes are categorized as topology nodes. These nodes help in accessing topology of a mesh at an index level. They function in a very similar fashion and hence I will explain one of them in a very detailed manner and then extrapolate the explanation for the rest of them. The first node we'll be looking at is the corners of edge node. This node outputs the index of a corner in a selected edge. The node uses the edge index to select edges and only finds the corners of those edges. After the edge returns its corners, they are unordered and grouped together. They need to be sorted for easier access. To do this, we use the weight input. You provide an attribute to this input and the node sorts the corners by that attribute, assigning them indices in descending order based on their weight. Now the corners can be accessed using the sort index assigned by the node. The higher the sort index, the smaller the weight. The outputs of this node include the corners index and the total corner count. Up next, we got the corners of face node. This node retrieves the corners of specified faces. Next is the corner of vertex node. This node retrieves corners adjacent to the specified vertex. Moving on, we got the edges of corner node. A face corner is always shared by only two edges. So this node retrieves the edges on both sides of a face corner. Up next, we got the edges of vertex node. This node retrieves the edges connected to a vertex. Next, we got the face of corner node. This node retrieves the face which is attached to a face corner. Next is the offset corner in face node. This node retrieves another corner in the same face as the input corner. And the last node in this section is the vertex of corner node. This node outputs the index of the vertex that a face corner is attached to. The next set of nodes are called utility math nodes. First of this is the Boolean math node. This node basically performs basic logical operations on its inputs. Next is the clamp node. This node takes in a value and sets a maximum and a minimum range the value can take. Next is the compare node. This node takes in two inputs and compares them to give a Boolean output. Next is the float curve node. This node basically maps an input float value to a curve. Next is the float to integer node. As the name suggests, the node basically converts a float value to an integer. Next is the hash value node. This node takes an input value and hashes it to an integer. Next is the map range node. This node remaps a value range to a target range. Next is the math node. This node is a really powerful node as it includes many math operations that can be applied to various inputs. The next set of nodes, I have categorized them under the miscellaneous category. The first of this is the for each geometry element zone. This zone type basically allows you to run a loop of operations for each element of an input geometry. Next up, we got the menu switch node. The menu switch node outputs one input based on a menu selection. Only the selected input is computed. Next up on the list is the index switch node. This node is like scrolling through a menu of outputs. To select a particular output, you choose a corresponding number, which is the output index. Next up is the random value node. This node outputs a random value for a given range of numbers. Next up, we have the repeat zone. This zone loops a set of operations on the selected input geometry for a specified number of iterations. Next up on the list is the switch node. This node outputs one of two values depending on the switch checkbox. The next section of nodes come under the read section in the curve nodes. The first of these nodes is the curve handle position node. This node outputs the position of the handles of a Bezier spline. Next is the curve length node. This node outputs the length of all the splines added together. Next is the curve tangent node. This node outputs the direction that a curve points in at each control point. Next is the curve tilt node. This node outputs the angle used to turn the curve normal around the curve tangent on the evaluated points of a curve. Moving on, we got the endpoint selection node. This node provides a selection for an arbitrary number of endpoints in each spline in a curve. Up next on the list is the handle type selection node. This node creates a selection filter based on the handle types of each control points. Next up is the is spline cyclic node. This basically tells whether each of the curve splines are cyclic or not. Coming up, we got the spline length node. This node outputs the total length of each spline as a distance or a number of points. Moving on, we got the spline parameter node. This node basically outputs how far along a control point is in the spline. The last node in this set is a spline resolution node, which basically outputs an integer value that corresponds to the number of points that will be generated between two control points. The next node is the only node in this section called the sample curve node. This node calculates a point on a curve at a certain distance from the start of the curve. The next nodes we are going to cover are called tool context nodes. The first being the 3D cursor node. This node allows you to bring in the information of the 3D cursor into the geometry node editor. Up next, we got the mouse position node. This node provides the location of a mouse cursor. Up next, we got the self object node. This node outputs the object that contains the geo node setup. Coming up, we got the view transform node. This node retrieves the view direction and the location of the 3D viewport. Coming up, we got the selection node. This node outputs true for the geometry which is selected in edit mode and false if it's selected elsewhere. Coming up, we got the active element node. This node outputs the index of the active geometry element in the specified domain. Up next, we got the set selection node. The set selection node allows you to control which geometry is selected using the selection node as input. Up next, we got the face set node. The face set tool in sculpting mode allows you to group faces by coloring the faces you want to be in the same group with the same color. This node outputs the face set index, which shows which face belongs to which set. And the last node is the set face set node. Yeah, that's a mouthful. This node assigns selected faces to a face set, which is specified using the face set input. Coming up, we got the Gizmo nodes. Gizmos are basically an interactive tool in Blender that allows users to control geometry node inputs directly through the 3D viewport. First, we have the dial gizmo. This is basically a circular ring. This node allows you to create angle changes. Moving on, we got the linear gizmo. This node creates a gizmo that moves linearly. And the last gizmo node we have is the transform gizmo. This node has the ability to control the position, rotation, and scale of the object it is applied to. Okay, the next set of nodes are called mesh operation nodes. The first in this set is the dual mesh node. This node transforms a mesh by placing a vertex at the center of each face, and these vertices are connected to form a new mesh, discarding the original geometry. The next three nodes I'm about to cover have almost the same functionality. The first node I'm talking about is the shortest edge path node. This node finds the shortest path along mesh edges, leading to selected set of end vertices. This node is usually paired with the edge paths to curves node or the edge paths to selection node. These both nodes are similar, just one of them gives selection booleans and the other one gives in curves. Up next, we got the extrude mesh node. This node lets you extrude selected parts of the input geometry. Up next is the flip faces node. This node reverses the order of vertices, which causes the face to be flipped. The most common use of this node is to flip the normals of a face. The next node in the list, mesh boolean node. This node is a direct replacement of the boolean modifier. Moving over to the mesh 2 points node, this node creates a point cloud from all the selected vertices of a mesh. Coming up to the mesh 2 volume node, this node creates a volume grid based on the input geometry's shape. Next is the scale elements node. This node scales connected geometry groups based on the specific value from the scale input. Coming up, we got the split edges node. This node functions like the edge split modifier, basically splitting and duplicating edges within a mesh. Moving on to the subdivide mesh node. This node subdivides the given input mesh by adding new faces. Up next, we got the subdivision surface node. This is similar to the subdivision surface modifier set to the Catmull-Clark mode. Up next, we got the mesh to curves node. This node basically converts meshes into curves. The last node in the list is the triangulate node. This node basically converts n-gons and quads in a mesh into triangles. Up next, we got the volume nodes. The first node in this list is the volume to mesh node. This node generates a mesh from a given volume. The last node in this section is the volume cube node. This node generates a 3D volume grid based on a density provided. The next section is the right section. First node in this section is the set curve normal node. This node allows you to control the method used to calculate curve normals. The next node in the list is the set curve radius node. This node allows you to control the radius of the curve set for each control point. Coming up, we got the set curve tilt node. This node controls the tilt at each control point of the curve. Moving on, we got the set handle position node. This node sets the position for the handles of Bezier curves. Coming up on the list, we got the set handle type node. This node sets the handle type for the points on the Bezier curve. Up next, we got the set spline cyclic node. This node controls whether each spline will loop back on itself, creating a cycle. Next is the set spline resolution node. As the name suggests, this node sets the resolution of a spline curve. Next up, we got the set spline type node. This node basically sets the spline type, which could be poly, Catmull, Rom, Bezier, or NURBS. The next set of nodes come under the operations section. The first of this is the curve to mesh node. This node converts all splines of a curve to a singular mesh. Moving on, we got the curve to points node. This node generates a point cloud from a given curve. Next up, we have the curve to grease pencil node. This node converts a top level curve to a grease pencil layer. Up next on the list is the deform curves on surface node. This node is used to adjust the position and the rotation of curves based on the changes in the surface they are attached to. Next is the fill curve node. This node is basically used to fill the faces in a cyclic spline. Next is the fillet curve node. This node rounds corners on curve control points, similar to the effect of the bevel modifier on a 2D mesh. However, a key difference is that the rounded portions created by the node are always portions of a circle. Up next, we got the resample curve node. This node takes in a standard curve as input and creates a new polyspline from it. Moving on, we got the reverse curve node. This node swaps the start and the end of the spline. The shape of the spline does not change though. Next is a subdivide curve node. This node adds more control points in between existing control points. Moving on, we got the interpolate curves node. This node generates a new curve on specified points by interpolating existing curves. The last node in this section is the trim curve node. This node shortens each spline in the curve by removing sections at the start and the end of each spline. The next set of nodes are called curve topology nodes. The first of this set is a curve off point node. This node takes in the value of a control point and retrieves the index of the curve it is a part of. Moving on, we got the offset point in curve node. This node allows you to retrieve other control points from an input control point. The last node in this section is the points of curve node. This node retrieves indices of specific control points in a curve. The next set of nodes we are going to cover are called grease pencil nodes. The first of this set is the named layer selection node. This node allows you to select and isolate layers by entering the layer's name in the input field. Moving on, we got the set grease pencil color node. This node allows you to change the color and the opacity of a grease pencil object. Up next, we got the set grease pencil depth node. This node allows you to order the grease pencil layers. Up next, we got the set grease pencil softness node. This node lets you control how soft or sharp a stroke's edge will appear. Up next, we got the grease pencil to curves node. This node converts a grease pencil setup to curves. The last node in this list is the merge layers node. This node combines grease pencil layers into a singular layer. The next set of nodes are called hair nodes. These nodes are used to create hair systems all through geometry nodes. The first section we will look at, which are called generation nodes. The first of this section is the duplicate hair curves node. This node duplicates hair curves a specified number of times within a given radius. Next up, we got the generate hair curves node. This node creates new hair curves on a mesh surface. The last node in this section is the interpolate hair curves node. This node creates hair curves by interpolating between existing guide curves on a mesh surface. The next section are called deformation hair nodes. The first node in the list is the blend hair curves. This node blends hair curves between guide shape curves. Up next, we have the displace hair curve node. This node basically displaces hair based on an input vector. Up next, we got the frizz hair curves node. This node deforms hair curves to create a frizz effect by rotating each control point along a random vector. Moving on, we got the hair curve noise node. This node deforms hair curves using a noise texture. Up next, we got the roll hair curves node. This node rolls hair curves along their length. Up next, we got the rotate hair curves node. This node basically rotates the hair curves around a specified axis. Moving on, we got the shrink wrap hair curves node. This node shrink wraps hair to a mesh surface. Up next, we got the smooth hair curves node. This node smooths the shape of hair curves. Coming up, we got the straighten hair curves node. This node straightens hair curves while keeping the tips and roots fixed in position. The last node in this section is the trim hair curves node. This node trims or scales hair strands to a specific length. The next section is called read nodes. The first of this section is the curve info node. This node gives vital information about each curve. Next is the curve root node. This gives information about the root of each curve. Next is the curve tip node. This node gives information about the tip of each curve. Next is the curve segment node. This gives information about the curve's segments. Last is the hair attachment node. This node reads information about the attachment point on the surface mesh. The next section are called the utility hair nodes. The first of this section is the attach hair curves to surface node. This node allows you to attach hair curves to a mesh surface. Next is the redistribute curve points node. This node redistributes control points evenly along each curve. The last node in this section is the restore curve segment length. This node restores the length of segments after deformation. The next section in hair nodes is the guide nodes. The first of this set is braid hair curves node. This node transforms existing hair into braids. Coming up, we got the clump hair curves node. This node clumps together existing hair curves using guide curves. Moving on, we got the create guide index map. This node is responsible for creating a new attribute called guide curve index that stores the index of the nearest guide curve for each hair curve. Last of this set is the curl hair curves node. This node deforms existing hair curves into curls using guide curves. The last node we are going to cover in hair nodes is the set hair curve profile node. This node sets the radius of hair curves according to a profile shape. Coming up next, we got the utility field nodes. Remember, one of the few nodes we tackled in the starting was the attribute statistic node. The major downside of that node is that it requires a geometry to function. And so in the new Blender 4.5 update, Blender added 3 new nodes to carry over statistical operations without needing to input a geometry. These nodes are the field min and max node, field variance node, and the field average node. Up next, we got the accumulate field node. This node is easier to understand on the spreadsheet, so I'm going to do that. The basic function of this node is to add the input field values based on the geometry's indices. Instead of outputting a single total value, it returns the current value at each element. The next node in the list is the evaluate at index node. This node allows access to an element's attributes using its index. The last node in the list is the evaluate on domain node. This node basically allows you to switch the domain of the attribute you input into it. The next set of nodes are called instance nodes. The first in the set is the instance on point node. This node basically allows you to instance an object or a collection of objects onto the points of another geometry. The next node in the list is the instances to points node. This node basically takes in instance geometry as input and generates a point at the origin of the top level instances. Next in the list is the realize instances node. This node basically makes instances into real geometry data. Next in the list is rotate instance node. This node rotates the instances around a pivot point whose location can be specified. Next in the list is scale instance node. This node scales selected instances around a center point which can be specified. Next in the list is translate instance node. This node basically translates the selected instances. Next in the list is set instance transform node. This basically combines the functionality of rotate, scale, and translate instance nodes into one single node, and it does this by using a transformation matrix. Next in the list is instance transform node. This node basically outputs the transformation matrix of each top level instance in a given geometry. The next two nodes are pretty similar in function, the instance rotation and instance scale node. These nodes basically output the rotation and the scale of the top level instances respectively. Now we're going to take on one of the most biggest and the most complex set of nodes called mesh nodes. The first node in this section is the edge angle node. This node calculates the angle in radians between two faces meeting at an edge. The next node is the edge neighbors node. This node outputs the number of faces sharing an edge. Coming up, we got the edge vertices node. This node outputs the position and the index of the two vertices of each of the mesh's edges. Up next, we got edges to face groups node. This node clubs together certain faces into regions which are surrounded by selected boundary edges. Next up on the list is the face area node. This node outputs the surface area of each face of a mesh. Moving on, we got the face group boundaries node. This node finds the edges which lie on the boundaries of a specified region. Coming up, we got the face neighbors node. This node outputs the vertex count and the face count of each face of a geometry. Up next on the list is the is face planar node. It outputs a boolean indicating whether a face is planar or not. Moving on, we got the is edge smooth node. This node outputs true for each edge of a mesh that is not marked as sharp. Up next on the list is the is face smooth node. This node outputs a true value for each face of a mesh that is marked as smooth shaded. Moving to the meshed island node, this node provides information about disconnected regions of geometry, also called islands, within a single mesh object. Coming up, we got the vertex neighbors node. This node outputs the vertex count, which is the number of vertices connected to this vertex with an edge. The next collection of nodes are called sample nodes. The first of this collection is the sample nearest surface node. This node retrieves attribute values of the closest point on the surface of a source mesh geometry from a sample position. The last node in this group is the sample UV surface node. This node finds an attribute on a mesh surface at a specific UV location. The next few nodes we are going to cover are those nodes which I missed while recording initially and the new nodes added to Blender 4.5 update. So let's go over them. The first node I'm going to cover is the string length node. This node outputs the length of a string you input in it. Up next, we got the find in string node. This node searches for a smaller string within a larger input string. Up next, we got the match string node. This node compares parts of two strings and gives a Boolean result based on whether they match or not. Up next is the format string node. This node basically allows you to dynamically change strings using Python style formatting or the Blender's format specifier syntax. The next node we are going to look at is the instance bounds node. This node outputs the minimum and the maximum extent of all the top level instances in a geometry measured in 3D space. Up next, we got the camera info node. This node allows you to output the information about the selected camera object. It takes the active camera and outputs its internal parameters which can be set in the camera tab. Up next, we got the bitmath node. This node basically allows you to do bitwise math directly in Blender. Up next, we got the vector curves node. This node takes in a vector as input and maps its individual components to a curve. Up next, we got the mix node. The basic gimmick of this node is that it allows two inputs to blend with each other. Coming up next, we got the set shade smooth node. This node controls whether a mesh's face will appear smooth in the viewport and renders. Up next, we got the set mesh normal node. This node lets you assign custom normals to a mesh. Up next, we got the smooth by angle node group. This node sets the sharpness of a mesh's edge based on the angle between its neighboring faces. Up next, we got the named attribute node. This node is used to retrieve any attribute that is saved onto the geometry. Up next, we got the simulation zone. This node basically lets you change a geometry setup over time. Anything inside the zone gets iterated over every frame. It lets the result of one frame affect the next, creating a geometry setup that changes over time.